So today we're going to be talking about 12.2, analyze arithmetic sequences and series. So in an arithmetic sequence, the difference of the consecutive terms is constant. So in my pattern, I'm going to be adding or subtracting by the same number throughout the entire pattern. This constant difference is called the common difference. And we denote it with the letter D. So when we look at these arithmetic sequences, we need to figure out, okay, am I adding by the same number to get the next term, or am I subtracting by the same number? If so, then it is an arithmetic sequence. So let's look. I have negative 4, 1, 6, 11, 16. Well, to get from negative 4 to 1, I'm adding 5. To get from 1 to 6, I'm adding 5. 6 to 11, add 5, and 11 to 16, add 5. So yes, I have an arithmetic sequence. If I look at B, to go from 3 to 5, well, I'd be adding 2. To go from 5 to 9, I'd be adding 4. 9 to 15, I'd be adding 6, and then 15 to 23, I'd be adding 8. I don't have a common difference in this pattern, so this is not an arithmetic sequence. Two more examples below, just going over the same idea. To go from 7 to 13, well, I'm adding 6. 13 to 19, adding 6. 19 to 25, adding 6. So yes, I have an arithmetic sequence. To go from negative 8 to negative 4, well, I'd be adding 4. Negative 4 to 0, I'd be adding 4. 0 to 6, I'd be adding 6, and then 6 to 12, I'd be adding 6. I'm not adding by a common difference here, so this is not an arithmetic sequence. So we have a rule when we're writing arithmetic sequences, and the nth term of an arithmetic sequence with the first term a sub 1 and a common difference d is given by, so I write the rule as a sub n equals a sub 1, meaning my first term in my sequence, plus n minus 1 multiplied by d. So n is the value I'm working with, so if I had a sub 15, I'd be plugging 15 in for n. And d, of course, is that common difference. So if I look at the example, it says the nth term of an arithmetic sequence with a first term of 2, so this is my a sub 1 here, my first term, and a common difference is 3, so that's the d. So if I was going to write a rule here, it would be a sub n equals a sub 1, my first term is 2, plus n minus 1, and then d is 3. We don't want to leave it like this. We want to simplify it always. So from here, this is going to be 2 plus 3n minus 3 for a final rule as negative 1 plus 3n. So then this would be my rule for this sequence. So if I look, it wants me to write a rule for the nth term of the sequence, then find a sub 15. Well, they tell me 4, 9, 14, and 19. Well, they tell me my first term of a sub 1 here is 4. Now I can figure out the common difference by looking at my pattern. To go from 4 to 9, well, I'm just adding 5. 9 to 14, adding 5. 14 to 9, adding 5. So that makes my d here 5. And I can write my rule from here. So a sub n equals my first term, which is 4, plus n minus 1 times my d, which would be 5. Always want to simplify it, so it's going to be 4 plus 5n minus 5 to give me a sub n equals negative 1 plus 5n. And this would be my rule. Now they asked me to find a sub 15. All I'm doing here now is instead of n, I'm replacing n with 15. So negative 1 plus 5 times 15, that's going to give me a sub 15 equals 74. The second example below, I go from 60 to 52, 44, 36. So if you'll notice now, I'm decreasing my value, so I know I'm going to have to be subtracting. And I'm actually subtracting by 8 is my pattern. My first term is 60, so when I write my rule, a of n equals 60 plus n minus 1 multiplied by my d, which in this case is negative 8. So when I simplify this out, I get 60 minus 8n plus 8, or I write my rule as a sub n equals 68 minus 8n. And then when I go to find a sub 15 here, it's just going to be 68 minus 8 times 15. So I get a sub 15 is negative 52. You look over on the next page, you're doing the same exact thing, except they're do-it-yourself. So I'm hoping that you're pausing this video and actually trying them on your own. I have provided you with the answers here so that you can check them as you go. Our next example is going to ask us to write an arithmetic sequence. It's telling us that a sub 19 is equal to 48, and the common difference is d equals 3. So the first thing they want us to do is write a rule, and then they want us to graph the sequence. We're going to be looking at geometric sequences in the next couple of days, and we want you to be able to see how these look graphically. So first we'll start by writing the rule. Well, I know that my generic rule for arithmetic sequences is a sub n equals my first term plus n minus 1 times d. This time they don't tell me my first term, but I can plug in what they do tell me. So I can take this a sub 19 equals a sub 1. I don't know what my first term is. I know here I'm talking about n is 19 minus 1, and they tell me my d is 3. So from here, I can simplify this. They tell me a sub 19 is 48 equals a sub 1, and then 19 minus 1 would be 18. So this would be plus 18 times 3. And if I simplify that, I'll get a sub 1 equals negative 6. So this now is my first term. I'm not done, but now that I've solved for my first term, I can now write a rule for this arithmetic sequence. So it's going to be a sub n equals negative 6 plus n minus 1 multiplied by 3. Always want to clean it up. So that's going to be a sub n equals negative 6 plus 3n minus 3. And my final answer here is a sub n equals negative 9 plus 3n. So it requires us to do a little more work before we're actually able to get our final answer here. They also ask us to graph to kind of see what this is look like. So before I jump right to my graph, I'm going to set up a table for my n values and my a sub n values. So we'll just look at the first 6 terms. So if I plugged 1 into my rule, I would get negative 6 out. We knew that because we knew our first term was negative 6. And then from here, all you're doing is plugging these values into your rule to get your a sub n value out. And if we graph this, so 1 is negative negative 6. 2 is negative 3. 3 is 0. 4 is 3. 5 is 6. And 6 is 9. And if you look, I don't want you to draw a line here. We just want to see what this represents. And if you look, you will see that arithmetic sequences are just representing linear. You would get a linear type feature on your graph. So that is something to note. If you flip over to the next page, you do have a do-it-yourself here. So I'll give you the rule, and I will let you graph that on your own. So you should get your final answer for your rule is a sub n equals negative 34 plus 11n. So if we look at this next example, we're doing the same thing as before. We're still writing the rule for the nth term, but we have to do a little more work to be able to get this rule. So they do tell us that it is an arithmetic sequence. A sub 8, is equal to 21, and a sub 27 is equal to 97. So we're going to have to use this information. So let's start. They tell me that a sub 27 is equal to 97. So I know that a sub 27 is equal to a sub 1 plus 27 minus 1 times d. That's just taking a sub 27 and plugging it into my arithmetic rule. And we know this is just 97 equals a sub 1 plus 26 times d. Now if I do the same thing with a sub 8, which they tell me is 21, I'll have a sub 8 equals a sub 1 plus 8 minus 1 times d. So then this is 21 equals a sub 1 plus 7 times d. Now I have two variables that I'm looking for. Remember, I need to find a sub 1 and d in order to write my rule. So what I'm going to do is I'm going to solve this equation, and it really doesn't matter which one you work with here, for a sub 1. So if I solve this for a sub 1, I'll get a sub 1 equals, all I'm going to do is move the move the 7d over by subtracting it. So negative 7d plus 21, or 21 minus 7d, however you want to write it. Then I'm going to take this now and plug it in to my second equation and solve for d. So I'll have 97 equals negative 7d plus 21 plus 26d. Now if I simplify that, I'll get 76 equals 19d, and then d is equal to 4. So once I find my d value, I take that d and I go back to this equation, and I'm going to plug 4 in for d. So I'll have a sub 1 equals negative 7 times 4 plus 21. And when I simplify that, I get a sub 1 equals negative 7. So now I have found my two pieces of information that I needed, and I can write a rule from there. So this is going to be a sub n equals my first term, which is negative 7, plus n minus 1 times d, which is 4. If I clean this up, I'll get negative 7 plus 4n minus 4. So I get my final answer for my rule is a sub n equals negative 11 plus 4n. So ultimately, we're doing the same thing. They're just giving us less information here. I'm going to let you try the next example below, you should get your final answer as a sub n equals 28 plus 12n. And if you have questions on that, we can answer those tomorrow in class. Alrighty, we have one more example that we're going to go over before stopping for the day. I'm going to go over one of these and then I'm going to let you do the next two on your own. So first they want us to write a rule for the nth term of the arithmetic sequence, and then they want us to find a sub 20. So if I look at this first example, to go from 17 to 14 to 11 to 8, I know my numbers are getting smaller. Here I'm actually subtracting 3, so that's my D value. My first term is 17. So if I have a sub n equals 17 plus n minus 1 times negative 3. And if I clean that up, I get a sub n equals 17 minus 3n plus 3. So I get a sub n equals 20 minus 3n as my rule. And to find a sub 20, all I'm going to do is plug 20 in for my n here. So a sub 20 is equal to 20 minus 3 times 20, which gives me a sub 20 equals 40. So I'm going to let you do the next two examples. You need to write a rule and find a sub 20. So for B, hopefully you'll pause these and try it, or after you see the answer, try them. A sub n equals 20 minus 7n, and a sub 20 equals negative 120. And for C, a sub n equals negative 9 plus 5n, and a sub 20 equals 91. Hopefully you were able to get these answers, and we will be practicing this more tomorrow in class. We'll pick up the rest of the notes for tomorrow's homework. Have a fabulous night.